Hello student, welcome to my official YouTube channel, Mathematics All Levels. And today this is the first video of exponential and logarithmic function. So today we are unlocking the major concept of logarithms. So let's begin. Okay, what if I say you, I'll directly come to the concept. What if I say that 2 raised to the power x equals to 8? So it is easier for us to calculate it. Why is this so? That is 2 raised to the power x equals to, we can directly write 8 as 2 raised to the power 3. Okay, from here we can say that the value of x will be equals to 3. But what if I say that if 2 raised to the power x is equals to 50? Okay, so we can see here that x will not be a whole number here, and it will be difficult for us to find the value here, value of x here. So this is where the logarithm comes to rescue. Think logarithm as the logarithm as the inverse operation of indices. Inverse operation of indices, just like operations of indices. Just as addition is the inverse operation of subtraction, multiplication is the inverse of division, exponential will be inverse of logarithm. Okay, so let's see its major component and major parts. For example, let's say log of n base a equals to x. First, how we need to pronunciate it this part will be that log of a base to natural number n is equals to x, or simply we can say that in the other form of mathematics we can say that a raised to the power x equals to n. They both are same. Okay, this how we need to pronunciate it in that form of mathematical language is we can say that log of a base to natural number n will be equals to x, and for this we can directly say a raised to the power x equals to n. What is base here? This part I'll be highlighting it. Yeah, this is the base, student. Okay, this is the natural number n. This is the this is the uh, this is the power. This is the natural number n. This is the base. Okay, there are certain conditions. Base will be must be positive and it can't be equal to 1. This we'll see into the later part of this video, that it must be positive and it should not be equals to 1. Okay, this base part, this is the actual n, which is the value for which we are actually calculating it. This is the exponent or power, we can say this is the exponent power. That is what we are solving for here. This is the natural number and this is the value n. It must be positive, and think this as a part or this as a target number is our target number. For example, whatever we need to calculate, for example, this is the part a and this is x. Okay, so what we can say from here, that the value of n will be equals to a raised to the power x. Okay, we will come to this part and we'll solve some of the questions regarding to related to this concept. Now let's move ahead. We have two special properties, students, for this concept, which we'll be discussing in this part only. That is log of 1, log of a base to 1 will be equals to 0, and log of a base to a, log of a base to a will be equals to 1. This how we can say this. We can directly solve it here, that log of a base of 1 will be equals to 0. When we'll expand this form in terms of mathematical logarithmic form, So we can say from here that 1 will be equals to a raised to the power 0, and we know that 1 will be equals to a raised to the power 0, and a raised to the power 0 is equals to 1. This we already know. Similarly, what if I say for this part, that is log of a base to a will be equals to 1. So if I write this again, that will be log of a of base a equals to 1. So in terms of mathematical logarithmic form, we can say that a will be equals to a raised to the power 1. That is true. So this is the two special properties, students, which will be required for us. That is log of a base to 1 will be equals to 0, and log of a base to a will be equals to 1. Okay, now let's move ahead. Yeah, some of the common mistakes which students does here is mixing up the bases. For example, what if I say let's take an example, 7x negative of 50 is equals to 49. So what maximum students will do here, okay, they'll mix the base. For example, if I say this, we have taken 7 raised to the power x negative 50 equals to 49. So how could we rewrite this form? So remember, the equation which we have learned before was log of a base to the power n will be equals to x. So from here we can say a raised to the power x equals to n. Okay, this we have learned before. So similarly, how we can write this here, this part, this equation here. Okay, in terms of mathematical logarithmic form, how we could write here is directly log of 7 raised to the power, this is x negative of 50. Okay, so this will be 49 equals to x negative of 50. So maximum student, what they will do here, which will be wrong, so I'll be rewriting it with the red marks, which will be not correct. They'll be writing that log of x negative 50 base of 49 will be equals to 7. Okay, so they will be mixing the bases, which will be the mistake. Okay, remember, this part will be the correct. Okay, this is not correct. Now comes to the next part, that is logarithm of negatives or 0. It will be always undefined. Okay, students, it will not be defined. For example, logarithm of any negative number, let's say negative of 5, or logarithm of 0, this all will be undefined. We can't find the value of these logarithms. Okay, if you want to explore it further, we can go it ahead also. For example, whatever base you are keeping here will not be able to get the negative part, and similarly whatever base you are keeping here, whatever base you are keeping here, you will not be able to get the value as 0. Okay, you can try this on your own and you can let me know. Second part is the most important, that is the forgetting restrictions. Means log of a base to the n will be equals to x. Okay, so for here certain restrictions must be there, that is a will not be equals to 0. Okay, and even a should not be equals to 1, and it must be positive. Similarly, n should be always positive. Okay, so logarithm, these are the main restrictions which usually student doesn't care about it. So we need to follow this as well, that these are the restrictions, that a can't be equals to 0, that base, and similarly a can't be equals to 1, and n must be the natural number which we are calculating here, that must be equals to must be greater than 0. Okay, it can't be 0 as well. So these are the mathematical necessities. It is not the means terms and condition. This is how we need to calculate it, and this only need to be followed anyhow. So let's move ahead. Yeah, now let's solve this. I've taken this part as an exam style mastery type of a question. So 7 raised to the power x negative 1 equals to 50 in logarithmic form. So this we have already solved it, but again we'll solve it for you. That is 7x raised to the power x negative 1 equals to 50. Okay, so how we could write it? So we remember, you remember that we have written log of a base to n equals to x. So from here we can say a raised to the power x equals to n. So how we can write here? So in the logarithmic form, students, we can write logarithm of 7. This is x negative 1 raised to the power x negative 1, and this is natural number 50, so it will be equals to x negative 1. So this is the correct representation of logarithmic form of this question. Okay, question number 1. This is the correct representation. Don't get confused. Many of the students will mix the base. They will write it as log of x negative 1 base 50 equals to 7, which is wrong. Now let's move to this question, second part, that is log of x base 64 equals to 3. So if I decode it further, we'll get 60x log of x base to 64 is equals to 3. So when we rewrite it in the form of indices, so it will be equals to 64 equals to x raised to the power 3. So we already know that if we multiply 4 3 times, so we will be able to get the value of the left hand side, that is 64. So from here we can say that x, the value of x will be equals to 4. Okay, so this is the value of x here. If you are not able to do this part, so we can directly factorize it like this. Okay, and then we can solve it further. See, so this is the a factor of this 64. 3 times we can write it, and we can directly write the value of x equals to 4. Okay, let's move it. Let's move further. Now this is what we are expecting you all to do the problems here. That is, first part is converting it to the logarithmic form, and second is logarithm converting to exponential form. Third is solving for x, and fourth is evaluating log 5 base 125. So okay, I'll write it for you. I'll give a hint for you, students. So for this, if I say that what will be the logarithmic form, so this is r power, okay, and this is what the value is actually, and this must be in the base. Maybe you are getting my point. So we can directly compare it, and then we can write. Now this part, if I say, it is also very easy. We can directly write this is our base, this is the value which we are calculating for, and this is the power. Okay, similarly for this, we need to make the left hand side and right hand side equals. So it will be, means the base is x here, so this is the base here, and this is the value which we are looking for, and whatever value satisfies the left hand side will be the solution. And similarly we can solve this part as well by putting this value equals to x. Okay, we'll get the values here. In case if the values is not given on the right hand side, so we can directly substitute this value in equals to x, then we will be able to solve it, students. Okay, so what are the key takeaways from this session, students? That logarithm are the inverses of indices, and they log the exponential equations which we have discussed. And similarly, the fundamental definition, that is a raised to the power x equals to n, could be written as logarithm of logarithm of a base n raised to n equals to x. Okay, some of the special properties which we have discussed, that is the logarithm a base to 1 equals to 0 and logarithm a base to a equals to 1, which we have discussed and which we have proved also. Common mistakes which we have discussed was watching our base and remembering the restrictions, exam technique, converting between forms systematically. This was the key takeaways from this session, students. Hope you like my videos. Now, next I'll be uploading the part 2 of this concept, in which I'll be discussing the properties of logarithm. Be connected and don't forget to subscribe my channel. Thank you.